Hello everyone. First of all, thanks for attending to this talk. My name is Jorge Gómez Sanz and I am a researcher from the Universidad Complutense de Madrid. This talk will be about how to deal with plagiarism when you use a microblogging tool to support your lectures. It is known that plagiarism is a problem for us professors. We assume that students will behave ethically and provide works made by themselves and not by others. The problem is serious enough to have anti-plagiarism tools, very suitable for regular activities such as small text compositions, but unable to cope with other scenarios, such as material produced in social networks. This is a problem if you try to innovate and integrate new technologies in the classroom. In the case of microblogging networks, the problem is to determine if two students copy it, one from the other, considering a small text fragment of 140 characters. In this paper, the Bolotweet platform is considered. This platform is open source and allows you to ensure the privacy of students. The teaching method involves that at the end of the lesson, students reflect on what they have learned and try to write down within the text limit. Professors evaluate and score the annotation from 0 to 3, and the result is shown to the student. Professors can add feedback through the reply button, and students can improve their original annotation through the reply button again. In this scenario, it is very easy to see that given two students, one can repeat the annotation of the other with some minor changes, like replacing some word or altering the order of the words. But this is not the only problem. A student annotation scoring is private, but it's not unlikely that two students show each other how they were scored. In those cases, if two students write by chance something similar, it is natural that they ask for similar scoring. Hence, there is some pressure on the professor to be consistent in the scoring. To handle these situations, two concepts are handled: similarity and originality. The first refers to the similitude of the current annotation with the rest. It is automatically computed and informs the professor how were similar annotations scored. The second concept, originality, permits the professor to account how relevant was the idea with respect to the lecture content, or if this student was the first to write about the topic. These new two concepts are incorporated in the traditional interface as clickable squares in the top right corner. The algorithm to compute similarity considers two situations: when the annotation is inserted and when it is compared during the evaluation. In the first case, the words typed by the students are automatically processed using a multilingual thesaurus. For each word, all possible meanings are identified, and each occurrence is inserted in the database for later use. In the second case, a professor connects to the system and asks for similarity between an annotation and previously existing ones. This can be completed with just one SQL sentence, so the result is rather fast. The rows returned contain identifiers of other annotations, and reading those rows can give an idea of how many hits another annotation and the current one shares. This number of hits is used to generate a matching score as the proportion of hits with respect to the maximum number of hits. The result of this computation is shown in this slide. For each annotation, the top right corner shows two factors already presented: similarity and originality. Only those annotations with similarity over 0.5 are shown. Selected annotations also must have at least 4 shared words, whatever their meaning. The professor is presented with all these annotations satisfying this criteria, and ordered by the similarity. With this information, the professor is expected to decide which annotation is similar by clicking in the right hand and assigning an originality score to the annotation. This paper has introduced a tool that has been regularly applied during the last course. However, there is no formal account of the performance of the tool yet. There is no account of the false positives and false negatives that may have occurred during the course. However, we have the impression that the tool has been positive to create more homogeneous evaluations of the students and to identify some cases of plagiarism. The tool also relies strongly on databases. This makes the method potentially scalable to larger sets of users, though this remains as future case study. If you like the tool and want to give it a try, you can connect to the address presented in the slide and get in touch with me. Thanks for your attention. Goodbye.